If we're looking at vectors again, these are going to be problems that you probably know how to do, to be honest with you. So it's just a page of them. And we're just going to look at acceleration, equations of tangent lines, speed, and position. The big one's D, the position. It's something you can do, but it's an integral with an initial condition. Okay. So an object is moving along a curve in the xy plane and it has position xy at time t. And we have, whoops, how about we use the pen? dx dt and dy dt. Okay. At time 2, the object is at position 1, 4. Right. Find the acceleration vector for the particle at time 2. So, what are you going to do? Yeah, this is velocity, right? These are. So, make sure it's a vector. Fraction. Right? What's the derivative of sine t cubed? You guys are like, why are you bore us with such simple stuff? And I ask calculus AB and they're like, tangent. I'm like, oh, baseball. Okay. And then negative sine t squared times 2t. Okay, and then at time 2, plug time 2 in, right? So we have times 12. And
you can just leave it like that if it's a 3 1.
no.
Okay.
Make sure you're in radians mode. If you have a calculator, this is not evaluated yet, so make sure you finish it up and get negative 1.476 and 3.027. Okay.
If you weren't in radians mode and you got that far, would they account for the fact that you weren't in radians?
You would probably get 1, 2 points out of the 3. You would not get the answer point. But again, the day before the BC exam or the calc test,
Don't you change them for
we make sure those things are set up, and I put them in a box and nobody. So we shouldn't have to worry about that. All right, part B, write the equation of the tangent line to the curve at the point where t equals 2. All right, so if we want a tangent line, yeah. So dy dx right there, right? The nice thing is we've already done our derivatives, correct? Do we need these ones or these ones? Yeah, this one, right? So cosine t squared and sine t cubed, right? And then evaluate at time 2. So you get cosine 4 over sine 8. Anybody know that decimal? That's why you suck.
Well, it's kind of
See?
a problem.
That easy. Bam. All right, at time 2, we need a point. What is...
The object at time 2, the object at position of time.
Yep. All right, there you go. Something you already knew, right? Like, why do you bore us with such simple math? All right, speed. Those are two different formulas. They use the same thing, so what is it, Wyatt?
Should be square root of x followed by 2
Yeah.
plus y prime.
Yeah, so evaluated at time 2, right?
Right. Yeah, that's what I'm thinking.
So we already have x prime and y prime. And we've already evaluated them actually, haven't we?
Yep, they're all square.
Yeah, so sine 8 squared plus cosine 4 squared. Right, you guys can do that in the calculator, right? So, yeah, just make sure you know the difference between the speed. If we did arc length is the integral,
Right.
right? Speed is not, so.
So they have to be
But we are not given units, so we can just leave it. Right. Okay, here's the one that we just want to make sure we know. Find the position of the particle at time 1. Right. So we know x dt, correct? How do we get to position? No, those are velocity functions, right? So how am I going to find x equals? Yeah, so sine t cubed. What else do we need in there? Yeah. So if we want x at 1, our initial position at time 2, right? So this is where these can get a little bit confusing. This is time 1, not x is 1, right? So at time 2, x is 1. Okay. And we need to go from time 2 to time 1. Correct? Okay, so what you end up with is this integral.
Wouldn't it be 1 minus?
Yeah, I had these switched. So you start at time 2, go to time 1, right? So we have to switch them. So x at 1 is, and it's a calculator problem, so 0.782. Okay. But again, you've got 3 numbers here floating around, so keep those straight in your minds. The time, these are all in time, okay? So you're integrating time to get, this is your x position. So this will give you x position, and so will that. Okay. So be careful there. So what is our y at 1 going to look like? Right. Which again, if you don't have to do this, but you can. And that's 4.443. So your position, now is that a vector or a point? If I ask for the position of the particle. Yeah, it's a point, okay? There you go. Okay, so. Good. Good with that? Just remember to keep your time variables straight versus your X and Y variables. You'll get it. Okay, that's all I got. There's the sheet of work there. It should be 11 problems. And the homework, I have the answers. So if you need any answer help, you can do that.